Okay, here we are. AP Calculus. Let's see, where am I looking at? I'm looking at you. Okay. AP Calculus, we're doing 7.2. We're talking about the washer method. Now, in order to get ready for this lesson, I went to the hardware store and I bought a bunch of washers. Now, I'm trying to remember. Oh, here we go right here. Okay, look at these babies. Okay. We have some little baby washers. Ta-da! And we have some bigger washes. That's the New York coming out of me. And, well, all kinds of different sizes of washers. Okay? Just trying to clean up things around here. Now, so I've got a big one to show you. And we're going to use this idea of the washer to be able to use an upper function and a lower function and take volumes of some interesting pairs of functions. So let's get to it. Now you may remember I showed you this little movie. Here we go. Okay, folks, you may remember this illustration I showed you in the classroom. Now we're going to do the top one. So I'm going to say revolve. Okay, so notice it's called the washer method. See the washer being formed? Okay. All right, so that's good. Now we could adjust the inner radius. We could adjust the outer radius. Okay, R1. Well, they're calling that R outer, R inner. Okay, we get that. Here's a little deal where it's showing you like the locus of all of the different rectangles in there. So anyway, this is the washer method, and that's a tremendous illustration of that. We're going to use this in our study. They're talking about the washer method and how you could form a washer, right? Same thing as a disc, except we got a hole here. I'm going to call that big R and that little r, and that would be the width. And of course, it depends if we're doing, if we're using the x-axis or the y-axis for our dx or dy. A very good reading right there. I really do like it. Here's an example of where they are having two functions and then they revolve it around the x-axis. It is very helpful to visualize it. Now, here's example 3. So what we're going to do is we're going to just go through this problem and see if we could get the answer they do, 3 pi over 10. So let's do that. Hey folks, it's been a while since I've done this here, so all right, so let's see. We're doing example 3. And what we're going to do is we're going to recognize there's two functions here. Here's the square root of x, and then here is y squared. So I feel like I'm doing the y equals radical x, and then this other guy is y equals x squared. Okay, well, we want to revolve this region right here around the x-axis and figure out its volume. So that's kind of neat, right? Okay, well, they both stop at 1, and we're going to start it at 0. So we know the A and the B. The next thing to do is to draw the little rectangle. Now, I like to just draw one right in here. Here's my rectangle, okay? Now remember, that's going to be revolved around this axis right there. What I like to do is just sort of draw a little picture to the right. And a picture is worth 1,000 words. So here's my little guy. Remember, we're revolving it around, okay? Revolving it around. So you're just seeing half of the washer. Half of the washer. Okay, now remember, here's my axis of symmetry. Let me see if I could do this a little straighter here. That was pretty messed up. Okay, so this is the big R, and this is the little r. Okay, and we're going to put the formula down. Okay, so here's the formula. It's the, we're going to do that one little piece here, this piece right here. So it's the big R. In this case, it's going to be what? The upper one, which is radical x. And then the lower r, which is the brown one, which is x squared. Okay, so we're going to substitute them in here and then go from 0 to 1. Okay, there we have it right there. So now let's kind of finish this up. Now, we're going to have, that's going to be the square root of x squared is just x minus, that would be x to the 4th, right? Okay, dx. Now let's see, we're going to have to do, let's see, it's going to have to be pi times what? That would be 1/2 x squared, right? Minus what? 1/5 x to the 5th. And we're going to go from what? 0 to 1. Which, as we know, is pi times what? Blah minus blah. But now keep in mind here, because of this 0, that's just going to be 0. So let's go back over here and see if we can figure this out. Pi times what? Times 0 to 1, that would be 1/2 minus, we're going to put a 1, right? 1 in here, that's 1 times 1/5 is 1/5. Okay, now keep in mind, common denominator would be what? 10. So that would be 5 over 10 minus 2 over 10. Don't forget our pi. Or what? 3 pi over 10 cubic units, which does match what we need to do. So yay, I explained a washing method problem. Excellent. Now look at this next problem. This is example 4. In this case, we're going to do the washers spinning it around the y-axis. So remember, that would be delta y. And this one has 2 pieces to it. I'm assuming you looked at this already. So the shape is going to look like this, which is really cool. We're going to have to make 2 integrals, the bottom part and then the top part. Now remember, the greatest radius, or the big R, would be further to the right. In this case, it's 1. And then the little r, in this case, would be 0. In this case, would be that function. Remember, you're going to have to solve that for x. So here it is right here. X is equal to radical y minus 1. And of course, this is what the shape looks like, which is really cool. All right, so we know what the functions are. And so remember, we're going to have to add the 2 pieces together. So the volume of the first plus the volume of the second. Of course, this just reduces to 1. And remember, it's 1 minus that squared. So that simplifies to 2 minus y. And then remember, we're integrating, the variable of integration is y. So we just got to remember that. And we're going from 1 to 2. And then sure enough, I get 3 pi over 2. So I thought you may find that interesting. I really do like that. And here's a little image generated by Mathematica, which is a great software program. If you continue in math, I'm sure you're going to find out about that. So keep that in mind. Okay, I do want you to have a ball with example 5. Now, example 5, we're trying to find the volume of this solid. So it looks like a sphere, but it's got a hole in the middle, okay? And so here we go. Here's square root of 25 minus x squared. That's just a circle, right? Okay. And the hole's 3 up here, like 3 inches. And you can go read the problem, and you're welcome to, okay? And we're gonna set up the integral. Remember, the outer radius squared minus the inner radius. Inner radius is just 3. Remember, that's a circle. And we go through that process, and I get 256 pi over 3. So I thought you may find that interesting as well. In another video I want to show you. Now, I want you to know, I went back to the software I was using before. Remember, Miss Weeks made all of this stuff for us. And I put in that example 3 that we did, and I have a picture here. So what I'm going to do is I'm going to go and first I'm just going to sweep one washer. So here's one washer. Okay. Isn't that cool? Okay. Now I'm going to revolve the figure around the x-axis. I keep doing it and it gets finer and finer and finer, okay, which I think is really cool. So that's neat. And then what I'm going to do is I'm going to do this thing called accumulate, where I just go from all the way from the left to the right and just show you what's happening. We can find the volume. Okay, so remember, folks, that's the washer method. Now, the next video I will make is volumes of known cross sections, and we'll try to use some of Miss Week's stuff, and then we'll try to do the examples from the textbook so you have it. I wish you the very best. Don't forget, we're going to have office hours soon, and I will post that and send you a message on Schoology. Thanks.